No, today we are going to solve a question on linear programming, a very important topic in managerial economics. So now, linear programming as a whole is a technique that shows how to use limited resources of a business to maximize profit or to minimize cost. That is profit maximization and cost minimization. So linear programming is that technique that will enable you to use the little resources of a business to make profit or to minimize cost. As a matter of history, linear programming this technique was invented by George Zinc. It was invented by this man, George Zinc. So that's a brief history of this topic. Now we have a question here. This question is mathematically oriented. So we have a small manufacturer produces two products, X and Y, on two different machines, A and B. Product X requires 3 hours on machine A and 2 hours on machine B, whereas product Y requires 3 hours on machine A and 4 hours on machine B. Machine A can be operated for 18 hours a day, while machine B can be operated for 16 hours a day. The manufacturer earns a profit of 30 naira on each unit of product X and 40 naira on each unit of product Y. Wow, you see this question, it's a kind of complicated, but I'm going to break it in steps so that you can solve it with ease. So now, part A. For you to solve this question with ease, look at it very well. You have two products, X and Y. Two machines, machine A and B. So now, you have machine A. Machine A. And this one, machine B. So now, machine A is producing two products, X and Y. Machine B is also producing two products, X and Y. So for machine A, you have product X and Y. For machine B, you also have product X and Y. Now look at the working hours. That a small manufacturer produces two products, X and Y, on two different machines, A and B. Then product X requires 3 hours on machine A. That is X for machine A is 3 hours. 3 hours on machine A and 2 hours on machine B. Product X, 3 hours on machine A, 2 hours on machine B. Whereas product Y requires 3 hours on machine A, that is product Y. Look at product Y. Say 3 hours. Is it 3 hours? Whereas product Y requires 3 hours on machine A and 4 hours on machine B. 3 hours on machine A, 4 hours on machine B. Now, machine A can be operated for 18 hours a day. The total hours of operation for machine A, total hours. The total hours for machine A, total hours. The total hours of operation for machine A and total hours of operation for machine B. Total hours. Say that that machine A can be operated for 18 hours a day. Total hours for machine A is 18 hours. While machine B can be operated for 16 hours a day. Total hours of operation for machine B is 16 hours. Now if you look at this thing very well, you discover that we have two machines, A and B. So it therefore means that we are going to form two simultaneous equations, equation 1 and 2. So now for equation 1, you will have 3 hours for producing product X on machine A, 3 hours for producing product Y on machine A. It therefore means that you will have 3 times X, which is 3X, plus 3 times Y, which is 3Y. The total number of operations for machine A is 18. It therefore means that machine A can be operated for 18 hours exactly or less than 18 hours. So you will have 3x plus 3y is less than or equal to 18. Less than or equal to 18. Or if you want to simplify this thing further, you will say that 3x divided by 3 plus 3y divided by 3 is equal to 18 divided by 3. By so doing, you will have x plus y is equal to 6. So this is equation 1. So now, for this one, you will have 2 times x, which is 2x, plus 4 times y, which is 4y. Total number of hours for operating machine B is 16. It therefore means that machine B can be operated for less than 16 hours or equal to 16 hours, but not more than 16 hours. So you will have less than or equal to 16. If you still want to simplify this thing further, you divide both sides by 2 because 2 is common. 2 is a common factor, which is 2x divided by 2 plus 4y divided by 2 is less than or equal to 16 divided by 2. You will have x plus 2y less than or equal to 16 divided by 2, 8. This is equation 2. Now, we are done with the working hours. Now for profit, you see that the manufacturer earns a profit of 13 naira on each unit of product X. That is for profit now. Profit. See that for product X, total profit is 13 naira, and for Y, the manufacturer earns a profit of 13 naira on each unit of product X and 14 naira on each unit of product Y. Product Y, total profit of product Y is 14 naira. So now, if you want to get the profit function for this manufacturer, so that profit that let profit be pi. So by so doing, you will have pi is equal to 30 times x plus 40 times y, which is 40y. So the A part of the equation is provide a mathematical formulation of the linear programming problem. So now you will have to maximize profit. And the profit function is 30x plus 40y. Now you also have this profit maximization function is subject to some constraint. So the constraints are the two equations, equation 1 and 2 are the constraints. So this profit maximization is subject to this constraint and this constraint. And we say subject to the first constraint. The first constraint here, you can choose to use this one or this one. You can also choose to use this one or this one. So you will have subject to, this thing is less than or equal to. Less than or equal to. Yes. You will have subject to x plus y less than or equal to 6. You also have x plus 2y less than or equal to 8. So you are still supposed to have non-negativity constraint because x and y are products, so they are not supposed to be negative, they're supposed to be positive. So it therefore means that x is greater than or equal to 0 y is also greater than or equal to 0. If y is greater than or equal to 0, it therefore means that product y is not negative and product x is still not negative. So linear programming as a whole is divided into 3 parts. This first part here is a objective function. This is what you are supposed to find. The objective of this question is to maximize the total profit of this. So these two, this one is the objective function. Objective function. That is part 1. So this part now is a technical constraint. Technical constraint. Technical constraint. And these two, so the non-negativity constraint. Non-negativity. Non-negativity constraint. So this is the first part of this question. What you have here for like 6 lines, you have succeeded in simplifying it to this way. The first thing, divide the two. We have machine A and machine B. The details for machine A and the detail for machine A and for B have been drafted from this question. So this is the mathematical formulation of this linear programming problem. So if you have any question, drop it in the comment section.